thermodynamic surfaces. The matter discussed to this point can be well summarized by consideration of a pressure-specific volume, temperature, surface. Pressure specific volume and temperature surface. Two such surfaces are shown in these two pictures. Two types of the pressure specific value and temperature surfaces were shown in these two pictures. There is a difference between the two pictures. This picture 318 is the substance such as water. Such as substance, such as water, in which the specific volume increases during freezing. The specific volume increasing during the freezing, and in the chapter 319 the substance in which the specific volume decreases during freezing. Specific volume decreasing during freezing. In this diagram, the pressure, specific volume, and temperature are plotted on mutually perpendicular coordinates, and each possible equilibrium state is thus represented by a point on the surface. This follows directly from the fact that a pure substance has only two independent intensive properties. All points along a quasi-equilibrium process lie on PVT surface. For example, this is pressure, volume, temperature. Each point can be located on the surface. For example, this point, this point, this point, these all are the points in equilibrium. Points. See, such a process always passes through equilibrium states. The region of the surfaces that represented a single phase, solid, liquid, and vapor. We have also the pressure temperature diagram from this side. Excuse me. Vapor, liquid, and solid, and we have also a triple point here. These surfaces are curved The two-phase region, the solid, liquid, solid vapor, and liquid vapor region are ruled surfaces. The two-phase region, the solid, liquid, solid vapor, as shown here. For example, this is a liquid vapor, solid vapor, and triple line. Here are ruled surfaces. By this we understand that they are made up of a straight line parallel to the specific volume axis. We have also have pressure volume diagram in this part of the picture, with the critical point at top of the blue area in this picture, and solid vapor, liquid vapor phases, gas phases, liquid phases, and solid liquid phase here we have. By this we understand that they are made up of the straight line parallel to a specific volume axis. This of course follows from the fact that in the two-phase region, lines of constant pressure are also lines of constant temperature, although the specific volume may change. The triple point actually appears as the triple line on the PVT surface, this line and this point in this picture. Also we have triple line and triple point, and various solid liquid vapor areas for the substance that contrasts on freezing. The triple point actually appears as the triple line on PVT surface, since the pressure and temperature of the triple point are fixed, but the specific volume may vary depending on the proportional of each phase. Let me take a note for triple line. The triple point appear as triple line in the PVT, on the PVT surface. Since the pressure and temperature of triple point are fixed, but the specific volume may vary. Depending on the proportion of each phase. Of each It is also of interest to note the pressure, temperature, and pressure volume projection of these surfaces. We have already considered the pressure temperature diagram in this picture, and also we have the picture here for the expand on freezing material. The line of the distinguishes solid and liquid line. Is different with the substance that we have contracts on freezing. We have already considered the pressure temperature diagram for a substance such as water. It is on this diagram that we observe the triple point. Various lines of constant temperature are shown on the pressure volume diagram, this diagram and in this diagram, and the corresponding constant temperature section are located identically on the PVT surface. The critical isotherm has a point of inflection at the critical point. We have two critical points for the. Notice that for a substance such as water, which expand freezing, the expand on freezing is this diagram. The freezing temperature decreases with an increase in pressure. For a substance that contracts on freezing, the freezing temperature increasing as the pressure increases. Thus, the pressure of vapor is increased during the constant temperature line A, B, C, D, E, F. This A, B, C, D, E, F, A, B, C, D, E, and F. And from on the pressure volume, we have the line A, B, C, D, E, F. A substance that expands on freezing first becomes solid and then liquid. Expand, we have the first goes to the solid and then liquid, and for the contract, for the substance that contracts on freezing, the corresponding constant temperature line indicates that as the pressure on the vapor is increased, it first becomes liquid and then solid. This diagram. The difference between the two solid liquid area here, that the solid liquid area is this point, is that the first goes to the solid and the liquid, and in this case the substance goes liquid and then solid. The next section is the PVT behavior of low and moderate density gases.